Alright, so I'll keep this video as short as I can today. You have a quiz. Where's my pen? You have a quiz next class, which you should know, on reflections, so the little r, translations, capital T, and the capital R, which means rotations. Alright, so today we're going to look at symmetry. So right here, section 2.5, we're actually going to skip this page, and we're going to go on to the next one. Alright, so example 1, and don't worry about this opening exercise. Basically, when we reflect something, so I'm just going to make up a little triangle here. You don't even really need to draw it. When we reflect something, and there's my line of reflection, so I'm going to flip this shape right over our line, something like that. So there's my reflection. This line down the middle is also a line of symmetry. So a line of symmetry, and here's our definition. A line of symmetry is equidistant from all corresponding pairs of points. So it's just like a line of reflection. So what I'll ask you to do throughout this unit is identify lines of symmetry. Alright, so if we look at this shape here, we'll learn about this later, you've probably seen the term, this is an isosceles triangle. So we think, okay, where can I divide this shape so that it's equidistant on both sides? And you can probably tell if we cut it in half right down the middle, that's one line of symmetry. Let me grab a dashed arrow here, there we go. That's a line of symmetry right there. Fold it in half, right down the middle, and all the points are equidistant from that line of symmetry. Alright, so a couple more. Here's a nice rectangle. You can probably see we can cut it in half that way. We can cut it in half that way. What do you think about going corner to corner? If I fold it in half, if that's, my line of symmetry, does it look like this point is equidistant from that one? If I think about folding this over, it looks like that point's going to end up there. So be really careful. That actually is not a line of symmetry. So that right there that I'm flashing on and off, that is not a line of symmetry for that rectangle. Alright, so why don't you pause, try to draw in the next couple, and I'll unpause and I'll see how you did. Alright, looking at my third example, there's a lot of lines of symmetry there. So maybe the ones you wrote in, maybe you had found those two. Maybe if you fold it over onto itself, it's exactly the same. Maybe you saw that one as well if you kind of fold it diagonally. Maybe you also found that one. But if you kind of look really carefully, from every corner, you can also fold that thing exactly in half and it maps right onto itself. Alright? So there's all of them, I think. I don't think I missed any. What about that? You agree with me there or no? So if I fold, this is called a parallelogram, we're going to learn a lot about those later. If I fold this shape directly over that line of symmetry, remember it has to go straight down, and those don't match up. Kind of, sort of, looks like they do it first, but they don't. Same thing if you go kind of like our rectangle. If you go with that diagonal folds, it looks close, but if you fold your paper over, it doesn't perfectly match up. So this point, if you fold it over, it might end up right about there. It's just not quite perfect. So I think with that last shape, it looks like there's no lines of symmetry. Alright, so there's line symmetry. Rotational symmetry. It's not a fold that maps the figure onto itself. It's a rotation that maps the figure onto itself. So a rotational symmetry is a rotation that maps a figure back onto itself. So in regular polygons, and we'll learn about that later, polygons in which all sides are congruent, the number of rotational symmetries is equal to the number of sides of the figure. So here's kind of the easy way to think about it. You guys can take your paper. I'm just going to take my shape here. I set this up so I can just use my shape. If you turn your paper, you're going to keep turning until the shape looks exactly the same. So I'm going to turn it and boom. There's one rotational symmetry. So again, you guys can do this with your paper. Turn it, turn it, turn it, turn it. Boom, it looks the same again. That's my second rotational symmetry. Now I can turn all the way back to the beginning, and now it looks exactly like it did at the beginning. So in this case, there's 3 sides. So there's 3 rotational symmetries. And now what you might get asked is, how many degrees are in each rotational symmetry? So what's the angle of rotation? What's the degree of rotational symmetry? And to do that, we know there's 360 degrees in the circle. All right, to figure out how many degrees are in one of those single rotations, you just divide 360 by the number of turns. So for this equilateral triangle, there's actually 120 degree rotational symmetry, or 120 degree angle of rotation. All right, I think we're going to skip the rhombus for now, so don't worry about that one. Let's move on. Now we have a regular pentagon. So same thing. We want to turn it until it looks exactly the same as the original. There's 1 turn, the same. 2 turns, boom, same. 3 turns, same again. 4 turns, exactly the same. And you can see your paper, after you're turning your paper, it'll be right back to the starting point right now. So there were exactly 5 equal turns to make this shape look exactly like it did in its original spot. So to find how many degrees are in each one of those turns, we just take our full circle, we divide it by 5, and I believe that is 72 degrees. All right, you got the idea? I'm going to pause. I want you to try the regular hexagon. All right, so hopefully you saw you could turn your paper 1, 2, 3, 4, 5, 6 equal times to make it look exactly like it did when it started. 6 sides, that means 6 turns, 60 degrees in each turn. All right, and I think this probably makes sense, common sense type of definition here. Rotations of 360 degrees, so 360 just turns something back to its original, will always map the figure back onto itself every single time. This is called the identity transformation. All right, last one. Point symmetry. Point symmetry. So when reflecting an object through a point, the image and pre-image create point symmetry. And here's the key. With point symmetry, the object will look exactly the same upside down. So this picture to the right is a nice little example of point symmetry. So this is actually being reflected through the origin. So if you turn your paper upside down, these are actually the same exact shape. So you can kind of see where the reflection's happening. Point reflection, or point symmetry, that point is getting reflected through the origin and it ends up right there. So like that could be A and that could be A prime, for example. This point, you can see it goes through the origin, there's the point, and it's exactly symmetrical to that point on the other side of the origin. We'll talk a lot more about that in next class, but here's your easy way to determine if something has point symmetry. So again, it looks exactly the same upside down. So a nice way to remember it, point symmetry is the same exact thing as a rotation of 180. So if something has point symmetry, it means it can be rotated 180 degrees and it looks the same. So more paper turning. You'll take your paper. I'm going to do it just with this little turn like I did before. You'll turn your paper 180 degrees rotation. So now your paper should be upside down. Does this first shape look exactly the same right side up as it does upside down? Yeah, sure does. So this first shape has point symmetry. Next, take this pentagon. Careful now. Notice how the point is kind of going up in this one. We turn it all the way around, upside down. Boom. Now it's like that. That's a 180 degree rotation. Does it look exactly the same? No, it doesn't. It's close, but remember, it has to be exactly the same picture. So now the point's down. We turn it back to normal, and there the point's up. So since it doesn't look exactly the same as it does when it's original, it does not have point symmetry. All right, I'm going to pause, try the last two, and we're done. So we'll pause it and then check your work when you're done. All right, so my little picture of the sun here, we turn it exactly upside down. That's your 180-degree rotation. It looks exactly the same. So it definitely does have point symmetry. Same thing with the King of Hearts here. So if I ask you something has point symmetry, turn your paper upside down, see if it looks the same. All right, I will check these notes tomorrow. There's no online homework check. Just get ready for your quiz. All right, guys, keep up the good work. See you next time. Bye.